All right. So if I gave you a 1-3 in base 5, so make yourself a 1-3 with your base 5 blocks in one set. All right. So if you're on Zoom, you should have your base 5 blocks out as well. All right. And then in your other one, I want you to make 2-4. 2-4 with your base 5 blocks. Okay. Now, what we're doing is we're doing the Sept model that you had kind of on your test. All right. And when you have a Sept model and you're doing addition, you start with 2 distinct sets. And then what do we do with these 2 sets? We do what with them? We union them. All right. So we're going to union them. And most of the time, students will automatically group things that are alike together. That's just kind of what people naturally do. So when I group them together, I have 1, 2, 3, 4, 5, 6, 7. Why can't I write, if I'm adding these, why can't I write a 7 down there? What's wrong with writing a 7 down? I can't have a 7 in base 5. What's the biggest base value that I'm allowed in base 5? 4. So what's going to happen is you're going to have to make a bundle. Now, how do you know how many to put in your bundle? By the base. All right, so what's our base here? It's base what? 5. All right, so that means I'm not going to be able to write a 7 down. That means I've got to go over here to the 7 and I've got to take out a bundle. All right, so we decided how many's in our bundle. There are how many? 5, because it's base 5. Now in a minute, it's going to be base 10. How many will be in your bundle in base 10? How many will be in a bundle in base 10? 10. How many's going to be in a bundle in base 4? 4. How many is going to be in a bundle in base 8? 8. So there's a difference between how many is in a bundle and what's your biggest base value. Those are the same questions. Okay. So in base 5, my bundles are going to be in groups of what? 5. So I'm going to take 5 of these and make a bundle out of them. Now I'm going to remove that bundle. Now, when I remove that bundle, how many are left? 2. So that's what goes down is your remainder. But if you take away 5, you change the problem. So how are you going to fix the problem? In other words, if you take away 5 of those ones, don't you have to add one of these rods? So that bundle gets carried to the next column. And sure enough, how many of those rods do I have? I have how many? I have 4. Are we okay? All right, you do this one then. You make me a 3, 2, 3 in base 5. And then I want you to make me a 2, 0, 3 in base 5. You got enough to do that. So if you got enough to do that. So you got a 3, 2, 3 in one set, and you've got a 2, 0, 3 in the other set. So I'm going to have 3 little units. I'm going to have 2 rods, and I'm going to have 3 of those flats. All right, so we've got 3 of those, 2 of those, and then 3 of these. That's in one set. And in your other set, you have 2 of those flats. How many rods do you have in the next one? None. So I've got 2 of these. I don't have any rods, and then I've got 3 of those little ones. So is everybody okay on making the 2 sets? And what do we do with the 2 sets? We union them. All right, so we put them together. And naturally, they're probably going to group things that are alike. Now, when you add your ones, don't you have 6? Do I have enough to make a bundle? All right, so I'm going to take that 6 and I'm going to take out a bundle. How many are going to be in your bundle? 5. So there's going to be 1 left over, right? So do we understand that the 1 goes here and I carry my bundle? All right, so I'm bundling up 5. All right. And then I've got to add that rod. Now, how many rods are there? There are only how many rods? 3. Do I have enough to make a bundle? I don't. I just have 3 of those rods. Now, when I add up these flats, how many of the flats do I have? 5. Is that enough to make a bundle? Yeah. All right. So I take 5 and I take out my bundle. Now, again, how many are in your bundle? 5. So that leaves me how many? 0. And I would carry my bundle. Is everybody with me? So I'd have to remove these 5. I don't have enough room on the board to replace it with that big long one that folds out. Is everybody okay? Now let's do something without it being base 5. Let's make sure we're okay, because it won't always be base 5. And then we're going to move to subtraction. Okay. So what if instead I gave you this on the test? 6, 2, 7 in base 8 plus 1, 5, 3 in base 8. Now, if I'm in base 8, what am I going to bundle in groups of? 8. So I've got 7 and 3 is 10. Can I write down a 10? I've got to make a bundle, right? So when I make my bundle, when I take out my bundle, how many are going to be in that bundle? Remind me. 8. How did you know there were 8? Because it's base what? 8. What's that going to leave the remainder of? 2. So you put down the 2, the remainder, and you carry the bundle. All right. What does that column add up to be? What's 1 and 2 and 3 add up to be? 8. Can I make a bundle? Yes. Yes. So I take that 8 and I take out my bundle. And how many are in the bundle? 8. How many does that leave me? 0. So I put down the 0 and I carry my 1. That's my bundle. How many are in that column? 8. And again, if it's 8, I can take out 8 and make a bundle. So I'm going to have 0 and carry the 1, and I've got a 1. Is everybody with me? So you see why you've got 1, 0, 0, 2 in base 8. Now, does anybody have a question about adding another basis? Because that's the way I'm going to need you to teach base 10. Yeah.
It's like, I was just wondering, it's impossible to like add different bases, correct?
In other words, what you have to do is you have to make them match.
Okay.
In other words, if you had 1 in base 10 and 1 in base 8, you could change them both to base 10 or both to base 8. Just like you can't add inches and centimeters. I can't add X's and Y's. I can't add apples and oranges. I can't add fourths to thirds. So when you're adding, it's a very good question. Things have to be alike. That's right. Okay, any other questions or clarifications? Now, I need you to understand, you're not going to be teaching this. What you're going to be teaching is this. and 5 is what? 11, but you can't put down an 11. I do not want you telling a kid that you put down the right digit and you carry the left digit, because that's not going to work on time or money or fractions or anything else. What I want them doing is they're going to have those base 10 blocks, and I want them doing exactly the same thing with those base 10 blocks that you were doing the base 5 blocks. I want them to take those 11 units and I want them to take out a bundle. Now, how many are going to be in their bundles? Why 10? Because it's base what? 10. So they're going to have one little unit left, and they're going to carry that rod to the next column, their 10s. Now, how many rods, how many 10s will they have there? They're going to have what? 17. Again, I can't have 17 for a face value. So they're going to take those 17 rods, and they're going to have to make a bundle. How many are going to be in their bundle? 10. They're going to take 10 rods out. So that's going to leave them how many 10s or how many rods? 7. So they're going to write down their 10s in their 10s column. Now, what did they trade those 10 10s for? They traded them for 100 or a flat. Same thing, when you add this up, don't you end up with what, like 13 of them? I can't have 13 for a face value. So they're going to take those 13 flats and they're going to take out a bundle. They're going to take out 10 of those flats and have 3 of those flats left over. So hundreds go in the hundreds column. And they're going to trade it for that giant cube, which is their thousands. Everybody with me? And again, what's wrong here? They've got 10. They can't have 10. So when they take out 10 for their bundle, they're not going to have any left over. Do you see what they're doing? Because if they start bundling and unbundling and bundling and unbundling, and they get really good at it, they do it in kindergarten, they do it in first grade, they do it in second grade. When you start doing things like this, something took you 2 hours and 40 minutes to do. Your next task took you 1 hour and 35 minutes. And it says, how long did both tasks take? They're not going to say that it was 3 hours and 75 minutes. We don't do that. Is everybody with me? So they're going to have to bundle. What are they going to bundle in groups of with hours and minutes? Now they bundle in groups of what? 60. So they're going to have to take out 60 minutes because that's going to be their bundles. Everybody with me? And they're going to have to add what? One what? Hour. So the whole thing took them 4 hours and 15 minutes. Do you understand what I'm saying? When they start doing fractions later and you have 6/5, we're going to talk about later, this denominator tells you how many equally sized pieces make a whole. So every time you get a whole, you're going to make a bundle. So you have 6 pieces, you have enough to make a bundle. You can make one bundle and you have 1 piece left over. 1 whole, plus you have 1 piece, and it takes 5 equally sized pieces to make a whole. You have a 1 1/5. It's going to work with money and time and everything else, but we've got to do it correctly. All right, let's go back to subtraction with your set model. All right. Now, what happens if I tell you on a test to illustrate 5 minus 3 using the set model? With addition, you have 2 sets and you union the sets, okay? With subtraction, how many sets do you have? 1. That says you have a set with 5 and you take away, you remove how many things? 3 things from it. All right, so the same kind of thing here. I want you to make me 3 2 in base 5. Okay, so make a 3 2. Now, what I want you to take away is I want you to take away a 2 1 in base 5. So what am I going to remove from this set? How many units?
Yeah.
1. How many rods am I going to take away?
2.
2. 1 from 2 is still 1. 2 from 3 is still 1. I get a 1, 1 in base 5. And we would do several like that, because I want them to understand that subtraction means you start with a set and then you take away what's in the set. Just like if you had 25 minus 11. You'd have 2 rods and 5 little squares, so you take 1 away and have 4, you take 1 away and have 1. Base 10, base 5, same kind of thing. Now, what happens though if I have this? I want you to make me a 4, 2 in base 5. Okay, so take your base 5 and make me a 4, 2. Now, here's the problem. I want you to remove a 1, 3 in base 5. Now, what's the issue? What's my problem?
Don't have 3.
I don't have 3. I can't take away 3 unless I have 3. So on subtraction, instead of bundling, on subtraction, you're going to unbundle. So I'm going to have to remove one of these rods. What am I going to replace it with? What am I going to unbundle it into? I've got to take this away and put how many little more units over there? 5. Now I want you to stop and look at what you've got. Does everybody understand that you removed one of those? How many is that going to leave you? 3. Sure enough, it left you 3. Now, what did that one bundle get unbundled into? How many pieces? 5 pieces. Now, you already had what? 2 pieces, correct? How many pieces are sitting over there? How many ones are sitting over there? How many?
7.
You don't stick a 1 in front of it. That will not work. That 2 did not turn into 12. That 2 turned into 7. Now, why did it turn into 7? Because your bundle always unbundles into the number in your base. Is everybody with me? So that 1 rod turned into 5 little units, but you already had 2 units. So how many units do you have in all? 7. Now can you remove 3 of them?
Yeah.
All right, so if I remove 3, how many is that going to leave me? 4. And can I take one of these 3 away? Is that okay? So that's going to leave me how many? All right, are we okay? All right, you try this one for me then. Make me a 4, 1 in base 5. And I want you to take away a 1, 4 in base 5. All right, so you've got a 1, you got a 4, 1, and you take away a 1, 4. Now, if I got a 4, 1, what's my problem? I'm supposed to take away how many little ones? 4, but I don't have what? 4. So I'm gonna have to regroup, I'm gonna have to unbundle. So I'm gonna have to take away one of these rods. How many is that gonna leave me? 3. But what am I gonna do with this one rod? I'm gonna unbundle it. And when I unbundle it, how many pieces will I have? 5. So I add 5 pieces. So when I do that, what does this 1 turn into? The 5 pieces plus the one already has how many? 6. So does everybody understand how we unbundle and regroup? Now can I remove 4? Yeah. So when I remove 4, how many is that going to leave me? 2. And then when I remove one of these, that's going to leave me how many? 2. Everybody okay? Now let's try it without the pieces. What if I had this? What if I had a 1, 2, 1 in base 5? And I wanted to take out a 1, let's make it a 4 to make it something different. A 1, 2, 4 in base 5, and I want to take out a 1, 4 in base 5. Do I need to do any unbundling? No. I can take 4 from 4 and get what? 0. I can take 1 from 2 and get what? 1. And I can take nothing from 1 and get 1. So are you going to have to unbundle on every problem? No. Now, if I had a 1, 2, 3 in base 5, and I wanted to take away a 1, 4 in base 5, now am I going to have to unbundle? Yeah. So I can't take, now let me make sure we're clear about this. I do not want you telling the child you can't take 4 from 3. Because that's simply not true. Because when they get to 5th grade, they're going to take 4 from 3 and get a -1. And then they're going to wonder what else you lied about. Okay? So I've got a rule, and here's the rule. You cannot tell a child something that is not true for all time. Which means you got to be really careful how you phrase things. What you can say that is true for all time is you can't take 4 from 3 and get a whole number. Because later when they get a -1 is not going to be a what? A whole number. So I got to be real careful the way that I phrase things. So I can't take 4 from 3 and get a whole number, so I'm going to have to unbundle. So when I take one of these, that makes it a 1. Without the manipulatives, how do I know what this 3 turns into? What am I going to add to this 3? Why 5? Because that's the base. That's what you unbundle into. So that 3 plus that 5 turns that into a what? 8. Does it make sense where I got the 8? So 4 from 8 is what? 4. 1 from 1, I don't need to do anything. That's a 0. And nothing from 1 is a 1. Everybody okay? All right, what if you didn't have base 5? What if you had a different base? What if you had a 3, 1, 2, and this time it was base 4, and you're subtracting a 1, 3 in base 4? Can I take 3 from 2 and get a whole number? No. So I'm going to have to go over here and take one of these rods. Everybody with me? So that's going to leave me how many? 0. What am I going to add to that 2? Why 4? That's your base. So that rod would unbundle into 4 pieces because it's base 4. But you already had 2 pieces. So what's that going to turn into? A 6. It's the 2 you had plus the 4 you got when you unbundled. So 3 from 6 leaves me what? 3. I can't take 1 from 0. So I'm going to have to get another one. To get one of these, that's going to leave me how many? 2. What am I going to add to that 0? Why 4? Because it's base 4. So that's going to turn into a 4. Is everybody okay? So when I take 1 from 4, I'm going to get 3, and 2 minus nothing is 2. So I get a 2, 3, 3 in base 4. Now, what if I had this? This happens a lot. I have a 2, 0, 5 in base 8. And I want to take away a 1, 7 in base 8. I mean, obviously the top number is bigger than the bottom number, so I should get a whole number down here. Okay? But I can't take 7 from 5 and get a whole number. Now, what's the problem though? When I go here to get something, what? There's nothing to get. So I've got to go all the way, what? Over to here. Is everybody with me? So do you understand that I would take this flat? I'm going to take away a flat. That's going to leave me how many flats? 1. What am I going to unbundle it into? How many rods? 8. So do you understand? What am I going to add to this 0? I'm going to have to add a what? An 8. Now I'm still not better off than I was. Everybody with me? But now can I take one of these rods? And if I take one of those rods, that's going to leave me how many? And it's going to leave me 7. What am I going to add to this 5? 8. Why? Because it's base what? 8. That one rod would get divided or unbundled into 8 of those little squares. So what's that 5 going to turn into? What number? 13. But I can take 7 from 13 and get 6. I can take 1 from 7 and get 6. And I can take nothing from 1 and get 1. So that's exactly the way I need you to teach base 10. If I've got 963 and I'm supposed to take away 14. I can't take 4 from 3 and get a whole number. So I've got to come over here and take one of my 10s, one of my rods. That's going to leave me how many? 5. Now, I don't put a 1 in front of the 3. That's not what you're doing. What are you adding to the 3? 10, because it's base what? 10. That's why it becomes a 13. It's the 3 you had plus the 10 you got when you unbundled. So sure enough, 4 from 13 gives me what? 9. 1 from 5 is 4, and 9 minus 0 is still 9. Okay? So when you have a 203, and you're supposed to take away 15. Don't be slashing out this 0 and write down 9. I'll be real unhappy with you. I need them to understand where that 9 comes from. You can't take 5 from 3 and get a whole number, but there's nothing there, so you got to go get 100. So that's going to leave you 100, but that 100 unbundles into 10 tens. So what do you add to the 0? I'm adding 10. Then I can take one of those 10s, one of those rods away. That's going to leave me how many? 9. And then I can unbundle that rod into 10 ones, and that does turn into what? 13. But we're not just going to start slashing zeros out and throwing 9s above it. Doesn't make any sense. Okay? So part of your homework is going to be some more addition and then some subtraction on the bases. So does anybody have another question? Anybody have a question about doing the other bases? Are we okay? Now, the reason that we're doing the other bases, like I said before, is not because you're going to be teaching other bases, but I've got to get you to understand what's happening in base 10. And the only way I can do that is to get you out of base 10, because you know shortcuts. And slapping a 1 in front of it's not going to work with time or money or fractions or anything else. Okay? So, does anybody have a question or clarification before we kind of move on? All right, you can put those base 5 blocks up. We're done with those. And we're going to start talking about, I want to review real quick scratch addition, and we're going to start talking about multiplication. Now, y'all were on Zoom when we were doing scratch addition. So let's make sure we're clear about it. If you had 23,967 and you had to add 11,853, and then you had to add 6,929, and then you had to add 4,079. Now, we never teach scratch addition until I'd worked with those base 10 blocks over and over and over and over and over. Okay. Now, what you do in scratch addition is you trade as you go instead of waiting till the end. So every time I can make a bundle, I go ahead and make a bundle. All right. So do you understand what's 7 plus 3? 10. Can I already make a bundle? Yeah. So I have 10, and when I make a bundle, how many do I take out to make the bundle? 10. How many is that going to leave me? So do you understand? I had 10 little cubes, and now I've traded them for one. In other words, I don't have any. I have one rod, one bundle, and nothing left over after the trade. So I don't have anything to add to the what? To the 9. Now 0 plus 9 is 9. Do I have to make a bundle yet? No. But what's 9 plus 9? 18. Do I have enough to make a bundle? So what am I going to do? I'm going to take that 18. I'm going to remove 10 from my bundle. So that's a bundle. How many are going to be left over? 8. So at the end of all of this, how many little cubes do I have? I have how many? 8. How many rods? How many bundles did I make? I made how many? 2. So I carry them to the next column. Okay. All right. So next I go back and look, and I have 2 and 8. I mean, 2 and 6 is 8. Can I make a bundle yet? But what's 8 and 5? 13. So with 13, can I make a bundle? Yes. So when I have my bundle, how many will be left over after I bundle? 3. And then what's 3 plus 2? 5. Can I make a bundle yet? What about 5 plus 7? What's that give me? What's 5 plus 7? 12. Can I make a bundle? All right. So when you make the bundle, how many are left over? 2. Because you have 12 and you take out your 10 for your bundle, you've got 2 left over. So after all of this, how many rods do I end up with at the very end of all that? I've only got how many? 2. How many bundles did I make? Did I make 2 bundles? So those go to the next column for my flats. What's 2 plus 9? 11. So I'll make a bundle. How many will be left over after I make the bundle? 1. And then 1 plus 8 is 9. Do I have enough for a bundle? No. What's 9 and 9? 18. So when I make the bundle, how many will be left over? 8. Now I'm adding 0 to that 8, which keeps it what? So at the very end of all that, how many do I have? I have 8. How many bundles did I make? Well, 2 plus 3 is 5, isn't it? Do I have enough for a bundle? Okay. What's 5 and 1? Do I have enough for a bundle? Now, what's 6 and 6? 12. So when I make the bundle, how many are going to be left? 2, isn't it? And then what's 2 plus 4? 6. Do I have enough for a bundle? No. At the end, how many did I have? I had 6. I only made 1 bundle, so I only carried 1. 1 and 2 is 3. That's not enough for a bundle. And 3 and 1 is 4. Still not enough for a bundle. So at the very end of all that, I had how many? So is everybody okay on scratch addition? So it didn't make sense last time. Is it better this time? We good? All right. Now, I want to talk about multiplication for a minute. Now, we talked about the model where you got multiplications, repeated addition. Okay? So if I want to do 2 times 3 using the set model, because I may ask you that on test 2. Okay. I may say illustrate 2 times 3 using the set model. If I say illustrate 2 times 3 using the set model, what does that mean you have to have? How do you do that?
Draw it out.
Okay, I could draw it out. What am I gonna draw? 2 sets of what? 3. Or what else could you draw? 3 sets of 2. It'd be your choice. Okay? So one of these are called factors. The things you're multiplying together are called factors. So one of the factors is the number of sets, and the other factor is what's in your set. Okay? So I've got 2 sets, and inside of each of those sets, I've got 3 things. And then it's repeated addition. What do we do with addition? We union, don't we? So I end up getting 6. All right. So that's how we do set model. Now, we teach kids their facts that way, and then all of a sudden, you want them to work this problem later in a grade. $246 times 327. Now, I want you to tell me what to do. I'm 10. Okay? So what do I do first? Meredith, what do I do first?
You multiply 6 and 7.
Okay, so I'm going to do 6 and 7. So what's that give me? 6 times 7 is what? Anybody? 42. Do I write down 42? Okay, what do you want me to do? You don't want to write down 42? What do you want me to do?
Put down the 2.
Put down the 2 and what? Okay, where am I carrying?
To 4.
Why am I carrying it over here?
Because that's the 10.
Okay, because that's the 10. That would make sense to me if I were 10. All right, carry that. All right. Abby, tell me, what do you want me to do next?
You multiply the 4 and 2, and then you add the remainder.
Oh, you want me to multiply the 4 and the what?
4 and 2, right?
The 4 and this 2?
Yes, ma'am.
All right. Anybody got something else you want me to do?
You multiply the 4 and the 7.
4 and the what?
7.
Okay, 4 and the 7. All right, how do I know which one I'm doing? Which one? How do I know which one I'm doing? Because it makes sense. If I did this one times this one, it makes perfect sense now to go do what? This one times what? That one. So if I'm 10, how am I supposed to know what to do next? The first thing makes sense. All right. So 4 times 7 was 42. So I put another 4 here, the 2. All right. If you want me to do 7 times 4, why did you decide to do 7 times 4 instead of 2 times 4? You're my teacher. How do I know what to do next? Amber, how did you decide? You said 4 times 7. How did you decide?
Yeah, that's doing everything on top and on the bottom. The way I was taught, we always did the first number and then the second number.
So when you said the first number, you're saying you were taught to start with this number.
Yes, and did 1, 5, 2, and the 4 and the 6 also.
So in other words, did you start here or start here?
I started with 6 and
And then you had to go this one times all of those. Is that the way y'all were taught? All right. So if I do 7 times 4, which I'm already confused because last week that was 40, but now it's 4. All right. 7 times 4 gives me what? 28. Annika, what do you want me to do next?
Well, you add the 4.
All right. Why do I thought I was multiplying. Suddenly in the middle of this multiplication problem, you want me to stop and do what? Add. Why? All right. So if I do 4 times 7 to get 28, and for some bizarre reason I'm adding 4 and getting 32, what do you want me to do now? So it's getting real fun now. Can I write down 32?
No.
No. So what do you want me to do?
Put down 2 and 3.
Okay, where am I carrying the 3 this time?
To the 2.
Why?
Because that's makes everyone.
Yeah, but you told me a minute ago to put it there because it was the 10, so that makes sense. But now I got 32, that's a 10, so you're telling me to put it in the hundreds? That makes no sense to me. Then what do you want me to do? 7 times what?
2.
But last week that was 200, but now it's back to 2, so I really don't know how to it just is. And then for some bizarre reason, after I multiply, you want me to stop and do what? add, now what do I get? 14 plus 3 is what? So I put down the 7 and carry the 1. Now suddenly you're coming in right down 17. And you don't be writing it here, you'll be writing it here. And then it gets really fun. What do you want me to do next? Why am I putting a 0?
Because we're starting in the tens.
Do you see what I'm saying? Then, in a minute, when I got 3 rows, what do you want me to do again in the middle of this multiplication problem? You want me to stop and do what? Does that make sense to anybody? No. No. You've memorized an algorithm, but you got no idea what you're doing. So you got no hope of teaching. Okay? So we're going to learn it a different way. Now, will we eventually get there? Yeah, we'll eventually get there. But we're not going to get there right this second. You see, I would move more from this to this. What does 2 times 13 mean I have? 2 sets of what? 13. All right, so does everybody understand? In one set, I've got 1 rod and what? 3 1. So in one set on my desk, I've got a rod. Now, how many is in my rod? And I've got 3 little ones. And then I've got another set over here, and I've got another what? Rod and what? 3 ones. Now, what am I going to do with these 2 sets? I'm going to do what with them? I'm going to union them. Now, when I union them, remember what I told you? Kids are automatically going to regroup. So they're automatically going to put these 2 together and these what? 6 together. They automatically do that. Now, what you just did was use a property. You just used the distributive property of multiplication over addition. Because here's what you did. 2 times 13. Isn't 13 a 10 plus a 3? Yeah. So you've been emphasizing to them for weeks now that that's 1 10 and 3 what? 1s. So what does that mean? That means you have 2 of the 10s plus you have 2 of the what? The 3s. You had 2 of the 10s and then you had 2 of the 3s. So sure enough, you ended up having 20 plus 6, which is what? 26. I'm going to do that over and over and over and over. Because I didn't understand that's exactly what's happening when I'm doing a problem like this. Suppose I want to do something smaller like 12 times 15. Do you understand that means I have 12 sets of what? 15. So I'm going to have enough so that I've literally got 12 sets, and I'm going to have a rod and 5 cubes in every one of those sets. So look what I've got. If I've got 12 times 15, that means I have 12 groups, and I've got 10 times 5 in each group. Is everybody with me? Now, what's a 12? Isn't a 12 a 10 plus a 2? So 12 times 15 means you have a 10 plus a 2, and you multiply it by 10 plus a what? A 5. Now, they're actually going to do the distributive property of multiplication over addition twice. All right, so from up here, does everybody understand? I'm going to have a 12 times a 10, plus I'm going to have a 12 times a what? A 5. But a 12 is a 10 plus a 2. So you've got a 10 times a 10, plus you've got a 10 times a 2. And you've got a 5 times a 10, and then you got a 5 times a 2. Same thing right here. Now, you're used to looking at this in an algebra situation, but think about how much better it would be when a kid got to pre-algebra if you taught them to multiply whole numbers like this. So do you understand that's this one times this parenthesis, and then that's this one times that parenthesis. So I've got 10 times 10, plus I've got 10 times 5, plus I've got 2 times 10, plus I've got 2 times 5. So I've got 100 plus 50 plus 20 plus 10. So I end up getting 100 what? 80? Now, 12 times 15. What's 5 times 2? 10. This 1 doesn't really stand for a 1. What's that 1? Because it's in that column. What's that 1 stand for? What number is that representing if it's in that column? So that's 110. So that's 10, isn't it? So what's 5 times 10? 50. Now, that's not really a 1, that's really a 10, right? Because it's in the tens column. So what's 10 times 2? 20. That's a 10 times another 10. What's 10 times 10? That makes sense to you. So when you come over here and you start this long thing that you were doing a second ago, I want you to understand where it's coming from. 5 times 2 is 10. So it makes sense to me to put down the 0 and carry the 1 to the tens column. This 5 times 1, this is 5 times 1, 10. That makes 5 tens. Plus 1 more tens is 60 what? Tens. Everybody with me? The reason there's a 0 here is because you're not doing 5 times 1, you're really doing 2 times 1, you're doing 2 times 10. So if you do 1 times 2 and you do 1 times 1, that's what I got. All right. So we start playing. Now here's what I want you to do with me. I want you to do this one. I want you to do it the way you learned it, then I want you to do 2 other things for me. Do this one. I want you to work 25 times 34 for me. Work that one the way you always have worked it. All right. So you did 5 times 4 was 20. So you put down the 0 and carried the what? The 2. And then you said 8 plus 2 was what? 10. Everybody okay? You put down a 0 here. I don't need that anymore. 5 times 3 is what? 15. Carry my 1. What's 6 plus 1? 7. So you don't get what for your answer? 850. Now instead I want you to work it this way. 25 times 34. 25 is 20 plus what? 5. All right, what's 34? 30 plus 4. I want you to use that distributive property of multiplication over addition and work it that way. It's going to work with it once a little better. So do we understand that's a 20 times this parenthesis, plus that's gonna be a 5 times what? That parenthesis. That's the first time I use the distributive property of multiplication over addition. Now I'm gonna use that property again. That's the first one times that one, plus the first one times that one. All right. So I've got 20 times 30, plus I've got 20 times 4. Plus I've got 5 times 30, plus I've got 5 times 4. So that gives me what? A 600 plus a what? 80 plus a what? 150 plus a 20. So what's that get me when I add all that up?
800.
Do I get 850?
Plus 750 plus 100.
Say that again, Amber.
It'll be 750 plus 100.
So which is
850.
850, that's right. So I get the same thing both times. Now, watch when you do this. 25 times 34. What's 5 times 4? 20. Now, is that really a 2? What's that 2 stand for right there? There's really a what? A 20. You see I have 4 groups of 20? So 4 groups of 5, do you see the 4 groups of 5 gives me the 20? Now I've got 4 groups of 20, which gives me what? 80. All right, I've got 4 groups of 20, which gives me 80. Now I've got 5 groups of 30. Is everybody okay? What's 5 groups of 30 going to get me? 100 what? 50. What's 30 groups of 20 going to get me? 600. So when I add all that, do you understand I still get 850? Now, you see these two things are the same as that. You see that these two things is the same as that. That's what you're doing when you're doing multiplication. Now, for most kids, you need to start with like a 2 times a 3 and then move to a 2 times a 13. Let them regroup with those base 10 blocks. Is everybody with me? Move them from that to this. This makes more sense to them. This will make a little more sense than this will. Okay? I mean, this will make more sense if they've done this. Now, think about why the algebra teacher is going to love you when they get them in algebra. This looks a lot like when they get to algebra, they're doing problems like this. Does this do you any good when you get to this?
No.
No. Does this do you good when you get to this?
Yeah.
Yes. So it needs to build on itself. If you're not going to teach them why this works, don't teach them this way. Do you know how to do lattice multiplication? All right, let's go do lattice multiplication. All right, now lattice multiplication is way easier than this. So if they're not going to understand what they're doing, let's just do that way. So if I've got something like 25 times 34, I'm going to make a block, a square, a rectangle. One number goes across the top and one number comes down the right side. So I'm going to have 2 columns and 2 rows. So I'm going to have a 25, and then I'm going to have a 34. Now, do we understand if I were doing 798 times 49? If I were doing that one across the top, I would have a 798. So do you understand that would mean 3 columns? And if I had a 49 on the right side, how many rows would I have? 2. So do you understand? You might get a square, you might get a rectangle. Now, what I need you to do next is this. I need you to draw diagonals from the top right to the bottom left in every one of those little squares. good? Now, here's the lovely part about lattice. Here's the way you spell it. It's lattice multiplication. Okay? Once you've got the block set up, you can jump around and multiply in any order you want to. If you want to run do 2 times 3 first, you can. If you want to run do 5 times 4 first, you can. You just got to fill it in. What's 5 times 3? 15. Why did I put it in that block? Because that's where that row and that column intersect. What's 2 times 3? How do you write 6 as a 2-digit number? What's 5 times 4? 20. What's 4 times 2? How do you write 8 as a 2-digit number? 0, 8. So does everybody understand where those green numbers came from, how I filled them in? Now here's the cool part. All you do is add along the diagonals. Like, do not use the original problem. That's why I put it in different colors. Everybody with me? So this bottom, you start at the bottom corner. This little triangle on the bottom corner is its own diagonal. So when I mean diagonal, I mean like this. Here, 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 and here. So do you understand what I mean by add along the diagonals? Okay? So the only thing on this one's just a 0. Does everybody see that? That diagonal's just a 0. What do you get when you add that diagonal up? Don't you get what? 5 and 2 is 7. What's 7 and 8? 15. So you put down the 5 and you carry the 1 to the next diagonal. What does that diagonal add up to? 1 and 1 and 6 and 0 adds up to what? 8, doesn't it? And that's its own diagonal, so it's a 0. So does everybody see where those numbers came from? Copy them from top left around. 0, 8, 5, 0. What number is that? 850. So let's go multiply 798 times 49. Okay. All right. 798. So that's going to give me 3 columns. And 49 is going to give me 2 rows. And I draw diagonals from top right to bottom left. So does everybody understand where those, how I drew that block? 798, 49. Now, you can jump around any way you want to and fill it in. What's 8 times 4? You tell me. 32. What's 8 times 9? 72. 9 times 4 is 36. What's 9 times 9? 81. 9 times 7 is, isn't that 63? And what's 7 times 4?
20.
So does everybody understand where those numbers came from? Now, I'm going to put a different color. Make sure we understand. I'm going to draw these diagonals in green to make sure we're clear. That's a diagonal. That's a diagonal. That's a diagonal. And that's a diagonal. So I'm not adding in columns like you're used to. I'm adding along diagonals. Now, do you understand that this red 2 is its own diagonal? So that's just a 2. Now add along this one. What's 7 and 2 and 1 going to give me? What's that going to add up to? 10. So I put down the 0 and I carry the 1 to the next diagonal. Is everybody with me? So I've got a 4 and a 6 is a 10 and an 8 is an 18 and a 3 gives me a what? What's that diagonal add up to? You got a calculator or a brain? What does it add up to? 21. So I put down the 1 and carry the 2 to the next diagonal. So what does that diagonal add up to be? 19. So I put down the 9 and carry the 1 to the next diagonal. Well, 1 and 2 is what? 3. So does everybody understand where these numbers came from? Just make sure you copy them from top left around. 39102, 39,100. Ain't that way better than the way you told me to mark when we first came in? Now, they don't understand what they're doing, but they don't understand, you don't understand what you were doing either. So I mean, if I'm not going to teach for understanding, I'd much rather do this one than the other one. Okay? Now, you do have to be able to do lattice for me. You do have to be able to do scratch addition for me. Okay? Because when you teach kids, you've got to have multiple ways of them doing something. Everybody's not the same. Just because something makes sense to me doesn't mean it's going to make sense to you. And it's my job to find something that makes sense to every one of you and every one of them. So you got to have more than just your favorite way of doing it. Okay? Everybody okay? Where's your homework going to be? On the Moodle. If you need some help, come see me. Okay? If there's anything that you can't do. All right? There's going to be a pop test thrown up on Moodle in the next, probably by tomorrow. Another video to watch. And some questions to answer on. Okay? The reason you watch the John Campbell one, in addition to that being, to me, very informative about coronavirus, you notice that's a geometric sequence because every time you get the next one is multiplying by what? By 2 when you're doing that illustration. Okay.